Welcome to our presentation on the IT management framework for a manufacturing enterprise. In today's rapidly evolving industrial landscape, the strategic management of information technology is no longer just a supporting function. It's a critical driver of success. This framework provides a comprehensive and structured approach to integrating IT with core manufacturing operations. It's designed to help organizations navigate the complexities of digital transformation, enhance operational efficiency, and ultimately gain a significant competitive advantage. Over the next few minutes, we'll explore how aligning IT strategy with business goals, fostering operational excellence, and embracing continuous innovation are essential for thriving in the modern manufacturing era. On this slide, we dive into the foundational elements of IT strategy and governance within a manufacturing enterprise. This isn't just about having an IT department, it's about making sure IT actively drives business success. First, we focus on strategic alignment. It's crucial that our IT strategy directly supports the core objectives of manufacturing, whether that's boosting production efficiency, enhancing product quality, or optimizing supply chains. This requires consistent collaboration between IT leaders and operational teams to ensure every technology investment delivers measurable business value. Think about establishing formal IT steering committees with manufacturing representation, developing key performance indicators that link IT efforts directly to manufacturing outcomes, and creating technology roadmaps that are perfectly synchronized with our production modernization plans. Next, we address the governance framework. Effective governance ensures our IT resources are allocated wisely and that projects consistently meet their objectives. In manufacturing, this means tailoring our governance approaches to account for unique production constraints and operational technology considerations. This includes implementing robust project portfolio management for all manufacturing IT initiatives, establishing change control procedures designed to minimize any disruption to production, and developing IT policies that are specifically suited to our manufacturing environment. Finally, we look at investment management. Investing in manufacturing IT means balancing immediate operational needs with future innovation opportunities. Sound financial management ensures our resources are directed towards initiatives that promise the highest business impact. This involves creating transparent IT budgeting processes that incorporate direct input from manufacturing, developing ROI models specifically for our manufacturing technology investments, and setting up regular review cycles to assess the performance and effectiveness of these investments. On this slide, we delve into enterprise architecture, or EA, which serves as the fundamental blueprint for aligning your IT systems directly with your core manufacturing business processes. A well-designed EA framework is crucial because it ensures that all your technology components work together seamlessly, supporting both your current operations and facilitating future growth and innovation. Manufacturing enterprises in particular face unique architectural challenges. This is largely due to the critical convergence of information technology, or IT, and operational technology, or OT. Your architecture must effectively address both traditional business systems and the specialized shop floor technologies. This requires careful consideration of security, reliability, and performance across all layers. We've outlined 4 key architecture domains essential for manufacturing. First, business architecture, which documents your manufacturing processes, organizational structures, and strategic objectives. Second, information architecture, defining how data models, flows, and governance are managed for both production and business data. Third, application architecture, mapping out all your software systems and their interactions across the entire manufacturing value chain. And finally, technology architecture, which specifies the underlying infrastructure components that support all your manufacturing applications. Effective EA also demands strong architecture governance. This ensures compliance with established standards and maintains alignment with your strategic business goals. For manufacturing, it's vital to establish architecture review boards that include representation from both IT and manufacturing operations to ensure all perspectives are considered. Finally, we address integration considerations. Manufacturing environments are complex, often containing numerous specialized systems that must exchange data flawlessly. Your enterprise architecture should clearly define the patterns, protocols, and middleware solutions needed to connect shop floor systems with your broader enterprise applications. We also highlight important reference architectures like RAMI 4.0 and the Industrial Internet Reference Architecture, or IIRA, which provide valuable frameworks as you embark on digital transformation initiatives.
This card delves into two indispensable systems for any manufacturing enterprise: Enterprise Resource Planning, or ERP, and Manufacturing Execution Systems, or MES. We'll explore their distinct roles and, most importantly, how their seamless integration drives operational excellence on the factory floor and across the business. First, let's look at ERP systems. These are the strategic backbone of your entire business. They integrate critical functions like finance, procurement, human resources, and high-level production planning. For manufacturing, a robust ERP ensures integrated financial management, efficient material requirements planning, optimized production schedules, and accurate inventory control. Think of ERP as managing the what and when from a comprehensive enterprise-wide perspective. Next, we have Manufacturing Execution Systems, or MES. MES acts as the vital bridge between the ERP strategic plans and the actual operations on the shop floor. It provides real-time production management capabilities, covering detailed scheduling, live production monitoring, labor management, and rigorous quality control. MES helps manufacturers understand the how and where of production, providing granular data on performance, including overall equipment effectiveness, or OEE. The true power, however, lies in their integration. Seamless ERP MES integration ensures a bidirectional data flow. This means information from the business side, like sales orders and material availability, flows down to the production line, and real-time production data flows back up to inform business decisions. This connection leads to highly accurate production planning, improved inventory accuracy by linking raw materials to finished goods, enhanced quality management through end-to-end traceability, and comprehensive analytics for continuous improvement. Selecting and implementing these systems requires careful consideration of your specific manufacturing processes, integration needs, and future scalability. We are increasingly seeing a trend where manufacturers adopt cloud-based ERP solutions for their flexibility, while often maintaining on-premises MES deployments to ensure robust production reliability and performance.
Moving on, let's discuss supply chain and supply chain management, or SCM. In today's dynamic manufacturing landscape, robust supply chain management is absolutely critical. It's about coordinating the flow of materials, information, and finances across your entire value chain, from raw material sourcing all the way to delivering products to your customers. Digital SCM solutions are key here, empowering manufacturers with greater visibility, resilience, and efficiency across their complex supply networks. This isn't just about managing logistics. It's about integrating across multiple tiers of suppliers, your internal production operations, distribution, and customer channels to ensure a seamless flow of goods. Some key capabilities that digital SCM provides include enhanced supplier relationship management through digital platforms, automating procurement processes, optimizing inventory levels with advanced algorithms, streamlining logistics management, including transportation and tracking, and robust warehouse management systems to optimize storage and shipping. These are the foundational elements of a modern, efficient supply chain. Beyond these capabilities, gaining comprehensive supply chain visibility and leveraging advanced analytics are paramount. This allows manufacturers to identify bottlenecks, mitigate risks, and continuously improve performance. With advanced analytics, you can proactively monitor supplier performance, optimize inventory based on real-time demand forecasts, analyze transportation costs, track sustainability metrics like carbon emissions, and even simulate various supply chain scenarios to build resilience. Ultimately, the seamless integration of SCM systems with your ERP and MES systems creates a complete digital thread. This digital thread connects your supply chain operations directly with production planning and execution, which is essential for achieving the agility and responsiveness demanded by today's competitive manufacturing environments.
This card focuses on IT operations, specifically IT service management and infrastructure within a manufacturing enterprise. In a manufacturing environment, IT operations are critical because they support not only traditional business systems, but also complex production systems demanding high reliability and performance. We start by looking at infrastructure management. This includes the foundational elements like network infrastructure that connects both office and shop floor environments, server and storage systems for all applications, specialized industrial networks for production equipment, and increasingly, edge computing devices that enable local processing of critical production data right at the source. Next, service management, or ITSM, is vital. It ensures the reliable delivery of all IT services to manufacturing operations. Key processes here include incident management, with a clear prioritization for production-critical systems, robust change management procedures designed to minimize any disruption to ongoing production, proactive problem management to address recurring issues, and service-level agreements that are closely aligned with the unique requirements of manufacturing. End-user computing in manufacturing also has its own set of unique needs. This isn't just about office workers, it extends to engineers and especially shop floor personnel. This requires specialized solutions like ruggedized devices for the harsh shop floor environments, mobile solutions for maintenance and quality control teams, high-performance engineering workstations for CAD/CAM applications, and digital displays for real-time production monitoring. Finally, continuous monitoring and operations are essential to ensure the optimal performance and availability of all manufacturing IT systems. This involves real-time monitoring of critical production systems, automated alerting and escalation procedures, diligent performance management and capacity planning, and robust backup and disaster recovery solutions to ensure business continuity. Ultimately, manufacturing IT operations require specialized knowledge and processes that effectively bridge the gap between traditional IT and operational technology domains. IT staff in this sector must possess a deep understanding of both business systems and the intricate production environments to provide effective support. Many progressive organizations are now adopting site reliability engineering, or SRE, practices to further enhance the reliability and performance of these critical manufacturing systems. Welcome to our discussion on cybersecurity and compliance, a critical area for any modern manufacturing enterprise. As IT and operational technology, or OT, systems continue to converge on the shop floor, new and complex cybersecurity challenges emerge. Manufacturing environments are unique because they often involve legacy production equipment, specialized industrial protocols, and the fundamental need for 24/7 operations. These factors create security complexities not typically found in traditional IT settings. The stakes are incredibly high here. A security incident in manufacturing can lead to severe consequences, from significant production downtime and safety risks to intellectual property theft and compromised product quality. Therefore, a comprehensive security approach must address these unique manufacturing-specific concerns, while also ensuring strict adherence to industry regulations. To tackle these challenges, we focus on two key areas: security architecture and security operations. For architecture, it's vital to implement segmented networks that clearly separate IT and OT environments. We also employ defense in-depth strategies for critical production systems, ensuring multiple layers of security. Secure remote access solutions for external vendors and maintenance personnel are crucial, as is robust identity and access management across both business and production systems. In terms of security operations, continuous monitoring of both IT and OT networks is essential for early threat detection. Vulnerability management procedures must be carefully adapted for production environments to avoid disrupting critical processes. We also develop specific incident response plans tailored for manufacturing scenarios, and we ensure security awareness training is provided to all personnel, including those directly on the shop floor. Beyond internal security, manufacturers must navigate a complex landscape of regulatory requirements.
These cover everything from information security and data privacy to industry-specific compliance. Key considerations include industry standards like IEC 62443 for industrial control systems and data protection regulations such as GDPR and CCPA. For those in critical infrastructure, NERC CIP applies, while medical device manufacturers must adhere to FDA requirements for product security. Furthermore, supply chain security standards like CMMC are increasingly vital, especially for defense contractors. Effectively managing this compliance requires seamless coordination among IT, operations, legal, and quality assurance teams. Many leading manufacturers are now adopting integrated GRC platforms, that's governance, risk, and compliance, to streamline these activities and provide comprehensive reporting capabilities, ensuring they stay ahead of threats and regulatory demands. Thank you.
Welcome to our discussion on data analytics and business intelligence, a critical area for transforming raw manufacturing data into actionable insights. As manufacturing enterprises, we generate an immense volume of data from every aspect of our operations, from the production line and supply chain to quality control and customer interactions. The key challenge and opportunity lies in harnessing this data effectively to drive operational excellence and inform strategic decision-making. On this slide, you'll see a pyramid illustrating the 4 key levels of analytics in a manufacturing context, building from the base upwards. At the foundation is data management. This involves the essential processes of data collection, cleansing, integration from diverse sources, secure storage, and robust data governance to ensure data quality and accessibility. Moving up, we have operational analytics. This focuses on real-time monitoring, setting up alerts for anomalies, generating daily reports, and tracking key production metrics to ensure smooth daily operations. Above that is tactical analytics. Here we delve into performance monitoring, identifying trends over time, and conducting root cause investigations to address inefficiencies or issues promptly. Finally, at the apex is strategic analytics. This level involves executive dashboards, sophisticated predictive modeling, and scenario planning, which are crucial for long-term strategic decisions and competitive advantage. On the left, we highlight several impactful manufacturing analytics use cases. These include optimizing production performance through OEE analysis and downtime tracking, enhancing quality management with defect analysis and statistical process control, and improving supply chain efficiency through inventory and supplier performance analysis. We also see applications in energy management and, critically, in maintenance optimization, paving the way for predictive maintenance strategies. To support these advanced analytics capabilities, a robust data architecture for manufacturing is essential. This architecture must be designed to handle the high volume, velocity, and variety of production data. Key components typically include data lakes for raw data storage, ETL, ELT processes for data integration, specialized time series databases for operational metrics, data warehouses for structured reporting, and user-friendly self-service BI tools to empower business users and engineers across the organization. By investing in these capabilities, manufacturers can gain unprecedented visibility into their operations, identify opportunities for improvement, and make data-driven decisions that enhance profitability and competitiveness. On this slide, we delve into the critical domain of IoT and the smart factory. This represents the next frontier in manufacturing, driving unprecedented levels of efficiency, automation, and insight. At the core, we have connected equipment. This is the foundational layer where production machinery, sensors, and devices are interconnected, enabling real-time data exchange. This connectivity allows for automated data collection, eliminating manual intervention, facilitates remote monitoring and diagnostics, provides centralized visibility across multiple production lines, and, crucially, enables seamless integration between machines from various vendors, a significant leap forward in operational transparency and control. Building upon this, we utilize industrial IoT platforms. These platforms serve as the essential middleware, connecting, managing, and analyzing the vast amounts of data streaming from your connected equipment. Their capabilities include robust device management, efficient protocol translation, edge computing for localized processing, secure data storage, and comprehensive application enablement, providing the backbone for your smart factory initiatives. Finally, these foundational elements pave the way for advanced applications.
We're talking about transformative technologies like digital twins, which create virtual replicas of physical assets and processes for simulation and optimization. Augmented reality for enhanced maintenance and training, autonomous material handling systems that revolutionize logistics, and adaptive production scheduling that responds dynamically to changing conditions. Implementing these technologies requires careful strategic planning and close collaboration between IT, operations, and engineering teams. It's not a big bang approach. Successful deployments typically begin with high-value use cases that clearly demonstrate a return on investment, then scale incrementally. Furthermore, adhering to industry standards like OPC UA, MQTT, and AMQP is paramount. These standards ensure interoperability between disparate systems and vendors, which is crucial for building a scalable and maintainable smart factory ecosystem. Moving on, let's discuss the role of cloud and edge computing in modern manufacturing. Cloud computing has fundamentally reshaped manufacturing IT by offering highly scalable and flexible resources. We see various deployment models here, including software as a service, infrastructure and platform as a service, private clouds for sensitive data, and increasingly hybrid clouds that blend on-premises with public cloud resources. Many manufacturers are now adopting a cloud-first strategy for new applications, migrating older systems to the cloud when it makes sense, which boosts agility, scalability, and cost efficiency. The benefits are clear: reduced capital expenditure on IT infrastructure, improved scalability for growth, enhanced collaboration across dispersed facilities and with partners, and easier access to advanced capabilities like AI and machine learning without massive upfront investments. It also simplifies overall IT management. However, the manufacturing floor often demands immediate data processing due to latency, bandwidth, and reliability needs. This is where edge computing comes in. Edge devices provide computing power right near the production equipment, enabling real-time data processing, local decision-making, even without cloud connectivity, and bandwidth optimization by pre-filtering data. It also ensures operations can continue during network outages and allows sensitive data to be processed within the facility itself. Ultimately, modern manufacturing architectures thrive on a balanced approach, integrating both cloud and edge computing. This hybrid model allows for time-sensitive operations to be handled locally at the edge, while leveraging cloud resources for large-scale data storage, complex analytics, and non-critical applications. This ensures data synchronization, centralized management of distributed edge devices, and graceful degradation should connectivity issues arise. It's about optimizing where data is processed to maximize efficiency and resilience. This slide delves into the transformative role of artificial intelligence and machine learning, or AI/ML, particularly in the manufacturing sector, with a strong focus on predictive maintenance. First, let's look at the AI/ML foundations. AI and ML technologies are revolutionizing how manufacturing operates. They empower systems to learn from vast amounts of data, identify complex patterns, and make accurate predictions, all without explicit programming. The core of these applications relies heavily on data from various sources: historical production and maintenance records, real-time sensor data from equipment, detailed quality inspection results, defect data, and critical process parameters, along with environmental conditions. This rich data landscape is what fuels the intelligence of these systems. Next, we highlight predictive maintenance, which is undoubtedly one of the most impactful applications of AI/ML in manufacturing. This approach utilizes data and advanced algorithms to anticipate equipment failures before they actually occur. An effective predictive maintenance program typically involves several key components: continuous condition monitoring using a network of sensors and IoT devices, sophisticated anomaly detection algorithms to pinpoint unusual or irregular patterns in equipment behavior, robust failure prediction models built upon extensive historical maintenance data, and the critical estimation of remaining useful life, or RUL, for vital components. Ultimately, This leads to optimized maintenance schedules and strategies, moving away from reactive repairs to proactive interventions. Finally, the business impact of successfully implementing AI/ML and predictive maintenance is substantial. For manufacturing enterprises, these technologies translate directly into significant benefits. A marked reduction in unplanned downtime and associated production losses, optimized maintenance costs achieved through condition-based activities rather than time-based ones, and extended equipment lifespan due to early detection and intervention. Furthermore, they enable improved spare parts inventory management and significantly enhance safety by preventing catastrophic failures before they happen. Beyond predictive maintenance, AI/ML extends its influence across numerous other critical manufacturing applications. This includes quality prediction to identify issues proactively, process optimization for automatically adjusting parameters for peak performance, and automated visual inspection for defect detection using computer vision. On the planning side, AI/ML aids in more accurate demand forecasting, intelligent energy optimization to reduce consumption, and supply chain optimization to predict disruptions and fine-tune inventory levels. These broader applications collectively contribute to a more efficient, resilient, and intelligent manufacturing enterprise.
This final card brings everything together by presenting an integrated IT management framework. The core idea is that for a manufacturing enterprise, successful IT management isn't about isolated components, but about how they integrate to deliver business value and enable digital transformation. As you can see in the diagram, the framework is built around several key pillars we've discussed. IT strategy and governance, which ensures our technology investments are aligned with business objectives, enterprise architecture, providing the blueprint for our systems, and the foundational ERP and MES systems that drive our core processes. We also integrate supply chain management to coordinate the entire value chain, robust IT operations for reliable service delivery, and comprehensive cybersecurity and compliance to protect our valuable data and systems. Each of these components, when working in harmony, contributes to a resilient and agile manufacturing operation. For successful implementation, there are critical success factors. First, cross-functional collaboration is paramount. IT, operations, engineering, and business teams must work together seamlessly. Second, we need strong skills development to bridge the gap between IT and OT domains. Third, effective change management is crucial as digital transformation impacts processes, roles, and organizational structures. And finally, a culture of continuous innovation is necessary to evaluate and adopt emerging technologies that provide real business value. The implementation approach itself should be phased. It starts with assessing current capabilities, identifying gaps, and prioritizing initiatives based on their business impact. We then develop detailed roadmaps for each component, establish clear governance mechanisms to coordinate all activities, and importantly, measure and communicate our progress regularly to ensure we stay on track and demonstrate value.